Have you ever gazed up at the night sky and wondered if somewhere out there someone might be looking back at us? It's a question that has captivated human curiosity for centuries, leading us to the exploration of the cosmos. As we delve deeper, we discover that the universe is teeming with a multitude of stars, many of which are orbited by planets outside our solar system known as exoplanets. These celestial bodies hold the potential to answer the intriguing question of extraterrestrial life. We've found thousands of these exoplanets orbiting in far-flung corners of the universe, each unique and mysterious. Some are icy giants, others fiery infernos, and yet a few remarkably similar to our home Earth. These Earth-like planets, found in the habitable zones of their stars, where conditions might just be right for life as we know it, are of particular interest. So, let's journey into the vast expanse of the universe and explore the fascinating world of exoplanets. Our story begins in 1992 with the first confirmed discovery of an exoplanet. This was not just any planet, but one orbiting a pulsar, a rapidly spinning neutron star that emits beams of radiation. Imagine a cosmic lighthouse spinning in the vast darkness of space. This pulsar, known as PSRB 1257+12, was found to be accompanied by not one but two planets, marking the first confirmed discovery of planets outside our solar system. These planets, aptly named Poltergeist and Phobetor, introduced us to the concept of exoplanets, planets that orbit stars outside our own solar system. And the significance of this discovery? It was the first hint, the first tangible evidence that our solar system is not unique in its ability to host planets. It was the first step towards understanding that our galaxy, and indeed the universe, is teeming with planetary bodies. But why are these exoplanets orbiting a pulsar so significant? Pulsars are the remnants of supernovae, the explosive deaths of massive stars. They are harsh, radioactive environments. The existence of planets around such a star not only challenged our understanding of planet formation, but also widened the possibilities of where we could find planets in the universe. In the grand tapestry of the cosmos, the discovery of these pulsar planets was akin to finding a needle in a cosmic haystack. It set the stage for a new era of astronomical exploration, sparking curiosity and fueling the desire to find more of these distant worlds. And find them we did. Over the next 3 decades, thousands of exoplanets have been discovered, orbiting stars of all different types, sizes, and ages. From gas giants larger than Jupiter to rocky worlds similar in size to Earth, the diversity and sheer number of these exoplanets have been nothing short of astonishing. This landmark discovery opened the door to a new era of astronomical exploration. And as we prepare to delve deeper into the cosmos, we stand on the precipice of potentially answering one of humanity's most profound questions: are we alone in the universe? As the 21st century dawned, our hunt for exoplanets intensified. The Kepler Space Telescope, launched in 2009 by NASA, opened a new chapter in this quest. It was designed specifically to detect Earth-sized planets within the habitable zones of their parent stars. Kepler was a pioneer, a silent sentinel in the depths of space, tirelessly searching for the telltale dip in starlight that signals a planet in transit. And oh, the worlds it found! The Kepler mission has discovered over 2,000 confirmed exoplanets. Among them are many gas giants reminiscent of our own Jupiter and Saturn, swirling with storms and girdled by rings. But Kepler has also found rocky worlds much like Earth, Mars, or Venus. Some of these rocky exoplanets are even located in their star's habitable zone, where the conditions could be just right for life as we know it. One of the most exciting discoveries was Kepler 22b, the first confirmed exoplanet in the habitable zone of a sun-like star. It's about 2.5 times the size of Earth and orbits its star in 290 days. We don't know if it's rocky or if it has water, but its discovery was a landmark moment. Then there's the intriguing system of Kepler 62, with not one but two potentially habitable worlds, or the ultra-cool dwarf star TRAPPIST-1, around which 7 Earth-sized planets orbit. The diversity of exoplanets Kepler has unveiled is truly staggering. These discoveries have revolutionized our understanding of the universe. We've gone from not knowing if there were any planets outside our solar system to finding thousands, each with its own potential for life. As we continue to explore, we're learning more about the conditions that might allow life to flourish, and realizing just how diverse those conditions might be. With each new discovery, our understanding of the universe expands, and the possibility of finding life beyond Earth becomes more tantalizing. But how do we, from millions of miles away, detect these distant worlds? Well, let's dive into the fascinating science behind exoplanet detection. The first method we'll explore is transit photometry. Picture this: you're gazing at a distant star and suddenly it dims, ever so slightly before returning to its usual brightness. What you've just witnessed is an exoplanet passing or transiting in front of its star. By observing these tiny dips in starlight, scientists can not only detect the presence of an exoplanet, but also estimate its size and orbit. It's a bit like playing cosmic shadow puppets, except the puppeteers are colossal celestial bodies. Next up is the radial velocity method, also known as Doppler spectroscopy. It's all about the wobble. Stars don't just sit still while their planets orbit. The gravitational pull from the planets causes stars to move in a small circular or elliptical motion. This movement alters the star's light spectrum. Think of it like the change in pitch you hear when a car zooms past you, except this time it's light instead of sound. By studying these shifts, scientists can infer the presence of an unseen planet and even estimate its mass and orbit. Now, these methods may sound complex, but they're the backbone of exoplanet discovery. Transit photometry and radial velocity measurements have already led to the discovery of thousands of exoplanets. They've allowed us to map out cosmic neighborhoods far beyond our own solar system, revealing a universe teeming with diverse planetary systems. However, it's not just about finding these distant worlds. These methods also provide crucial information about the planet's characteristics. They can tell us about a planet's size, mass, and orbit, which are key factors in determining whether a planet could potentially be habitable. So, as we scan the cosmos, these tools act as our eyes and ears, helping us uncover hidden celestial wonders. These revolutionary techniques have transformed our ability to search the stars for signs of other planets. Not all exoplanets are created equal when it comes to the possibility of hosting life. This is where the fascinating concept of habitability comes into play. But what does it mean for a world to be habitable? In the simplest terms, a habitable planet is one that can support life as we know it. This generally means a world that can maintain liquid water on its surface, not too hot that it all evaporates and not too cold that it all freezes. Now, you might be thinking, why are we so fixated on water? Well, every life form we know of, from the tiniest microbe to the largest whale, requires water to survive. It's the universal solvent, the medium where all the biochemical magic happens. So in our search for alien life, we're not necessarily looking for little green men, but we're looking for the telltale signs of water. So how do we find these potentially habitable worlds? Well, it's a bit like being a cosmic detective. Scientists look for biosignatures, or signs of life in the light that reaches us from these distant planets. These can be anything from certain gases in a planet's atmosphere that could indicate the presence of life, to the color of a planet's sky, or the light reflected off its oceans. Some of the most exciting discoveries in recent years include Proxima Centauri b, a planet located in the habitable zone of our nearest stellar neighbor, and the TRAPPIST-1 system, which boasts not one but 7 Earth-sized planets, 3 of which are in the star's habitable zone. These discoveries are tantalizing hints that we may not be alone in the universe. But finding these planets is only the first step. The next challenge is to study them in more detail, to understand their atmospheres, their climates, and their potential to host life. This is a monumental task, but one that scientists around the world are eagerly taking on. The search for a second Earth continues, and with each passing day, we inch closer to answering the question, are we alone? As we peer into the future, our quest to understand exoplanets and their potential inhabitants is just beginning. The next decade promises a flurry of missions and projects, each designed to take us one step closer to answering the question, are we alone in the universe? NASA's upcoming Nancy Grace Roman Space Telescope, with its advanced technology, aims to discover thousands of new exoplanets and provide unprecedented detail about their atmospheres. The European Space Agency's Plato mission, on the other hand, is set to scrutinize 1 million stars in our galaxy, in the hope of finding terrestrial planets in the habitable zones of their host stars. In addition, ground-based observatories are also gearing up with next-generation telescopes like the Extremely Large Telescope, which promises to revolutionize our understanding of exoplanets. So as we stand on the precipice of a new era in exoplanet exploration, the future is ripe with possibilities. As we continue to push the boundaries of our knowledge, who knows what astonishing discoveries await us in the cosmos?